In the last video, we built the foundation of the Taskmaster app, a PostgreSQL database running locally with a real-world schema for users, projects, tasks, and assignments. But right now, that database is sitting there in isolation. Your Next.js app has no idea it exists. In this video, we fix that. We're bringing in Prisma, a modern ORM that lets you query your database from JavaScript and TypeScript without writing raw SQL. We'll walk through the Prisma schema file, define our four models, wire up the relationships between them, and run our first migration. By the end of this video, your Next.js app and your PostgreSQL database will finally be talking to each other. Let's get into it. What is Prisma? Prisma is a type-safe ORM for Node.js and TypeScript. ORM stands for Object Relational Mapper. It's a layer that translates between your database's tables and rows and the objects and functions you actually write in your code. Instead of writing a SQL query by hand, you call a function like prisma.user.findMany, and Prisma generates the SQL for you behind the scenes. Here's why it matters for Taskmaster specifically. Full type safety. Prisma looks at your schema and generates TypeScript types automatically. If you rename a column or remove a field, your code won't even compile until you fix every place that used it. That's a huge win over raw SQL, where a typo in a column name only shows up at runtime. Prisma also gives us auto-completion in the editor, a clean migration system, and a query builder that reads almost like plain English. It sits directly on top of the PostgreSQL database we just built. Nothing about our schema changes. We're just giving Next.js a proper way to talk to it. Installing Prisma. Before we touch the schema file, let's get Prisma into the project. In your Next.js app's terminal, run npm install prisma-save-dev, followed by npm install @Prisma Client. The first package is the CLI, the command line tool you'll use to generate clients and run migrations. The second is the actual client your application code imports and calls. Once both are installed, run npx prisma init. This creates two things, a Prisma folder containing a file called schema.prisma and a database URL entry in your .env file. That schema.prisma file is the single source of truth for your entire database structure. Everything we do for the rest of this video happens inside it. The Prisma schema file and data types. Open schema.prisma. At the top you'll see two blocks Prisma generated for you, a generator block and a data source block. The generator block tells Prisma what to generate, in our case, client.js, the JavaScript client. The data source block tells Prisma which database we're connecting to. We set the provider to PostgreSQL and the URL to env of database URL. That pulls the connection string from your .env file. The same Taskmaster database we created with Docker or Homebrew in the last video. Now, data types. Prisma has its own type system that maps onto PostgreSQL types automatically. String maps to text or varchar. Int and bigint map to whole numbers. Boolean maps to true or false. Datetime maps to timestamp. And for our primary keys, we'll use string combined with a special default value, UUID, which tells Prisma to auto-generate a UUID, exactly like we did with PostgreSQL directly. You don't have to memorize the whole mapping table. Prisma's schema language is deliberately simple. You'll pick it up within the first two models. Defining models. User A model in Prisma maps directly to a table. Let's define our first one. Model user. Inside the curly braces, each line is a field, a name followed by a type. We'll write ID string with two attributes, @ID, which marks it as the primary key, and @default of UUID, which auto-generates the value, just like our UUID primary key in Postgres. Next, email, string, with @unique. This enforces the same not null and unique constraint we set up at the database level. Then, full name, string. Password hash, string, same rule as before. We're storing the hash, never the plain text password. And finally, created @datetime with @default of now. Prisma fills this in automatically on insert, same as our database default. Notice how closely this mirrors the actual PostgreSQL table from the last video. That's intentional. Prisma models aren't a separate abstraction layered on top of your database. They're a type description of the exact same structure. Defining models. Project next. Model project. ID string, primary key, UUID default. Same pattern every time. Title, string, description, string. But this time we mark it as optional with a question mark, since not every project needs a description. Created @datetime, defaulting to now. Now here's the important part. the relationship back to the user who owns this project. We add owner ID string. This is the actual foreign key column that gets stored in the database. Then, right below it, we add a second field, owner user at relation with fields of owner ID, references of ID. This second line isn't a column in the database, it's a virtual field. It tells Prisma, this project is linked to a user record and here's how to find it. That's what lets you write project.owner.email in your code and have Prisma automatically join the tables for you. Defining models task. Model task follows the same shape. ID string, UUID primary key. Title, string, description, string, optional. Status, string, defaulting to the string to do. Priority, string, defaulting to medium. Exactly the same workflow states we defined at the database level. Created at date time. And then the relationship. Project ID, string, plus a project ID field. And project at relation with fields of project ID, references of ID. Same pattern as before. One real foreign key column, one virtual relation field that gives you the typed navigable link back to the parent project. Defining models, assignment. And finally, the junction table, model assignment. This one connects tasks to users, so it needs two relation fields instead of one. ID, string, UUID primary key. Role, string, defaulting to contributor. Created at date time. Then task ID string and task at relation with fields of task ID, references of ID. Then assigned to user ID string and assigned to user at relation with fields of assigned to user ID, references of ID. And a third, assigned by user ID string and assigned by user at relation with fields of assigned by user ID, references of ID. Notice we have two separate relations pointing at the same user model, one for who the task is assigned to, one for who made the assignment. Prisma needs a way to tell these apart, so each relation gets a name. At relation of assigned tasks for one, assigned by user for the other. Without those names, Prisma won't know which foreign key maps to which relation, and your schema won't compile. Relations, one-to-many. Let's zoom out and talk about how these relations actually connect, because this is where a lot of people get tripped up. Take user and project. One user can own many projects, but each project has exactly one owner. That's a one-to-many relationship. On the project side, we already wrote the many side, owner ID, plus the owner relation field. But Prisma also wants the reverse side declared, so your user model can list all of that user's projects. Back in model user we add projects, project in square brackets. That bracket syntax means a list of project records. This single line doesn't create a new column in the database. It's purely for your application code. It's what lets you write user.projects and get back every project that user owns, fully typed with autocomplete. The same pattern applies between project and task. A project has many tasks, so project gets a tasks field, task in square brackets, right alongside its own title and description fields. Relations, many-to-many. Now the trickier one, many-to-many. Users and tasks are connected through assignment, and one task can have several assignees, while one user can be assigned many tasks. Prisma actually supports implicit many-to-many relationships, where it manages the junction table for you automatically. But we're not using that here, and there's a good reason why. Our assignment table isn't just a plain junction table. It carries its own data, a role field, a created at timestamp, and two separate links to user for who's assigned and who did the assigning. Whenever your junction table needs extra fields like that, you model it explicitly, exactly like we just did, as its own full model with two one-to-many relations, one from task, one from user. This gives you the same many-to-many behavior, but with full control and type safety over every field on that connection. Migrations and schema versioning. Now that our schema is fully defined, we need to actually apply it to the database. This is where migrations come in. Run npx Prisma Migrate dev, followed by -name init. Prisma compares your schema.prisma file against the current state of the database, generates the SQL needed to make them match, and creates a new folder inside Prisma/migrations, timestamped, with a plain SQL file inside it showing exactly what changed. This is schema versioning. Every time you modify a model, add a field, change a relation, rename something, you run migrate dev again, give it a short descriptive name, and Prisma generates a new incremental migration file. That folder becomes a complete, ordered history of every change your schema has ever gone through. It's checked into Git alongside your code, so anyone on your team, or any environment, including production, can run npx Prisma Migrate deploy and land on the exact same database structure, step by step, in order. This is a massive upgrade over manually running SQL files by hand like we did in the last video. No more wondering whether a teammate's local database matches yours. The migration history is the single source of truth. One more command worth knowing, npx Prisma generate. This regenerates the Prisma client based on your current schema, giving you fresh TypeScript types anytime your models change. Prisma actually runs this automatically after every migration, but it's useful to know it exists as its own command too. Recap. Let's recap what we covered. We installed Prisma and connected it to the PostgreSQL database from the last video. We defined 4 models: user, project, task, and assignment, each one mapping directly onto the tables we designed by hand. We wired up one-to-many relationships between user and project and task, and we modeled our many-to-many relationship through an explicit assignment model since it needed to carry its own fields. And we ran our first migration, giving us a versioned, trackable history of our schema. In the next video, we put all of this to work, using Prisma Client inside Next.js API routes to actually create, read, update, and delete data. You'll write your first real query and see the full type safety in action, from your database all the way up to your UI.